Okay, today talking about the final project for 6 CS50. It's called a Sortino ratio for stocks. So this is the information of my of this project versus and then the EDX username, the city and country, and then today's date. So the Sortino ratio is something that measures the how much life this a stock is having. It's modeled by two aspects of a stock over a period of time. It uses a desired return rate for the stock, like yearly return rate for the stock, and then compute the upside potential of the stock versus downside risk. So what is upside potential? It is for a given period of time, and say for a couple of months, how many times the stock actually outperformed the desired return rate. Downside risk is the standard deviation of those months, the return rate of those months that's below the desired return rate. So here, there's a formula here. As the ratio is the return rate minus the target return rate divided by the standard deviation. So to approximate that, I've written this program. You see, this program that takes a list of stocks, and then I'm giving a start date and an end date, and the desired return ratio is 8%. And then the span is something that I used for this program, is determine how many data points I'm going to use in order to compute this ratio, and how many months of data used to compute the tipping point ratio. I choose the 7, meaning that I will use the previous 6 months data plus this month's data to compute the tipping point ratio, which is the Sortino ratio. The reason that I use only 6 months is that I want the data to be sensitive to the market trend. I don't want to use the 1 year or 5 years that will smooth data out. So what I did in this program is I first go to Yahoo Finance and then download the history from the starting month to the end month. And then for each month, the return is a series. It's a data frame for pandas. So for I only look at the close data, the close stock price. So for that column, it is a pandas series, and then I can use percent change. That will give me the monthly return ratio for that stock. And then the first one, because you don't have the previous month, so it's a NA, so I'll drop NA to clean the data. And then for the yearly return, because Sortino ratio only operate on a yearly return, so I computed the yearly return by extrapolate the monthly return for over 12 months. So this is the formula I used, and I also has a unit test for that. Say the yearly return. So for example, if monthly return is this much, and then the expected yearly return should be this much, and then pass the unit test. How to compute the Sortino ratio, which is the tipping point ratio? I look at the yearly return, and then relative to the desired return ratio, which is 8%, and I only extract those months that's greater than the desired return ratio, and then that's I call the difference is the upside return, and then the ones that's below the desired return ratio, which is negative number, I put that into a downside return. And then the upside return potential is the mean value for the upside return, which is padded by zeros for those months that are negative. And the downside risk will be the standard deviation, which is computed by this formula for the downside return padded by zero for the months with the positive numbers. So the tipping point ratio will be the ratio of these two numbers. And then for the whole period of time, I kind of doing this rolling computation starting with the span, the 7 months. Like, so for example, for the first year, starting from January, so the first number I can get is from July. It will use the January to June's data plus July's data and compute the TPR, and then from July, August, all the way to the end of the month of the data, I will put that into a array, and then we'll return a series for that. And for each stock, I can get a PD series, and then for all the stocks, I will get a data frame. And then with this data frame, I can plot that with the X as the X label, axis was date, and then Y axis is TPR. And I also print that into a table and output, store those two results into output files. So I'll show you how the results, like for SPY is spider, QQQ, and then all these axis is the sectors. Like the XLK is the technology sector, XLE is the energy sector. So let me run this. Say Python. TPR. .py. Oh, what's going on? Yeah, .py over here. Okay, so it's running, and I will the starting data. I will use the last month of 2020, and then end date is the last month of 2012. And the actual yearly return rate was beginning with the January of 2020, because the first number will be discarded because it doesn't have a previous month's data. So the output will be listed in this table format. You will have the starting with 2021 January 1st all the way to 2022 and December 1st. So you can see the spider performance. You'll see that's first is in the beginning or in the mid of 2021 is doing pretty well. There was this infinite number. It means like the stock only goes up. It never goes. Only the stock all outperform the desired return ratio, and so that means that the downside risk is zero, which it will get an infinite. I did not use like the mean number for that. I just use the infinite number for authenticity here. So the spider is doing well in the mid of 2021, and around 2022 is going downhill, and the end of 2022 is going pretty okay. And then the technology sector, you can see that's also doing pretty well in the beginning, and at the end of around the beginning of 2022, it's going it's not doing very well. Any number that's less than 1 is negative return. So you will see okay, this is QQQ. So the technology sectors, you will see that in the 2022, the April and 2022 is not doing well in some of the months, and it's picking up at the end of 2022. And energy, you can see the energy sector is actually doing pretty well all the time during that period of time. And the output, I put it in the plot. So this is the plot from the data frame. You can see that the brown line is the energy sector is doing very well, and then the technology is XLK is doing well in the beginning, and then it does not perform as well as the energy sector during that period of time. And it also print out the results on the console. That's about it. It was fun. You can use this if you're interested. You can use this small program to test your own stock and for the given for any period of time of your interest. All right.